In the last video, I left you off with this map. So this map has a contour interval, which was given to us in meters, 20 meters. It also tells us the direction of north. And I asked you how many hills are there. And it looks like, remember, when there we have rings, we have some sort of hill. So 1, 2, 3, 4. Now, if I were to ask you where the point that, where is the grade steepest here? Where would you say? Right here, right? Where the lines are closest together. And if I asked you where is it flattest? That's actually tricky, but because there's a bunch of places, but anywhere where the lines aren't very close together, like here or over here. There seem to be 4 different hills, although this one's marking me a 200, which is telling me maybe this is a depression. Because if this is 200, this would be 220, 240, 260, 280, but this is 200, so maybe it went up and then down, and this one just doesn't have Hatcher lines. And then I asked you the direction of the water. Well, clearly it's going towards the ocean, but not just because it's the ocean, but because you see these U's or V's pointing this way, kind of big arrows, but water always goes the opposite way. Awesome. All right, so let's do a little exercise. Let's match the topographic map with its side view. So I would pause the video here and try to do it yourself before I solve it for you. All right. So number 1, which one do you think it belongs to? So clearly we have 2 hills, one that is flatter and one that is steeper here. So I think that belongs to B. Let me use a different color than black. How about blue? This should not be that hard. Okay, there we go. Let's look at number 2. Number 2 shows this one very even hill or mountain that just kind of goes straight up. It looks like E, right? In number 3, we have 2 hills. They're apparently kind of flat at the top because the rings don't continue uniformly, and they're very similar in elevation. So which one do you think? Now watch out, because A and D are very similar, as are 3 and 6. So which one do you think 3 belongs to? It belongs to D, right? Because the mountains are a little higher than A, which means A belongs to 6. And then 4 shows a range that leans towards the left-hand side. And 5 shows one that is flatter on top and leans towards the right-hand side. So this one's that one, and this one's that one. Not too bad, right? Great. Now, side views are a very important thing. They're called profiles, and we're going to talk about them in a minute. By the way, you may have noticed here this line XY. What that is a line to take up. It's kind of like slicing. We're going to talk about that here in a minute. All right, here's another map for you to practice with. So this one has summits. By the way, when you have 2 summits like this and an area around them that has the same elevation, that's called a saddle. M's also show these, it shows where kind of streams converge. We have a depression here. And we have, let's see, what's the interval? 850 and 825 split among 5 lines. It looks like it's again 5. There's a ridge line right here. Now, whenever you see V's, that's water. But if you see U's that are pointed in the opposite direction, it is actually telling you something about the geography that maybe has nothing to do with water. In this case, it looks like a ridge line. Okay, now you see here it points towards a steep slope because lots of lines together. Really flat areas over here, etc. So hopefully you're feeling a little more comfortable. Okay, so now sometimes you can, let's say that you went outside and you plotted these elevations. Well, it's like playing connect the dots, right? So this looks like after, let's say that you had all of these points and 5s and 6s and 7s, and after you connect all the 9s and all the 8s and the 7s and the 6s and the 5s, that you would end up with this, which looks like it's some sort of hill. That's great, and this is a very simplified example, but a lot of times the points that you collect are not evenly distributed, and sometimes you don't, actually, let me correct that. Most of the times you won't end up with these beautiful numbers like 8s and 9s. Let's look at this example. So in this example, we're going to try to connect the dots for, let's say that we want to make our interval every 2 feet. So we are going to do 460, 458, 56, 54, 52, and that's it. So 460 needs to start somewhere in between these two. So let's say it starts here, 460. Now I'm going to find all the points, in between which 460 occurs. So you're interpolating. This is 461 is too much, 459 too little, somewhere in between. 458, clearly this needs to go a little higher. 462, almost 3, and 458, it'll go somewhere here. And 461.1 is too high. 460 is too high as well. So we need to dip here, but then we need to bring it back because between 461 and 459 lies 460. So it ends up looking, and then you connect it with very smooth lines, or as smooth as you can, like that. And mine aren't smooth at all, but I try. All right, let's try for 458. So 458 would be somewhere down here between 458.8 and 457. 458 will also cross right between these two and down between these two, but closer to that point. Oh, actually, here we have the exact 458. And here it'll be somewhere in between these 2 points, maybe around here, and between 59 and 57, somewhere around here. So this one looks, and again, pardon my, it's actually kind of tricky to do with this screen pencil. Okay, let's do 456. 456 will be somewhere 455 and 71, somewhere over here. 56, we need to come in between these two, but really close to this one. Oh, actually, sorry, underneath, not above. You see? It's really easy to make mistakes. Okay. Pen. Okay. Underneath this one. And underneath this one. And really close to this one. And feel free to do your own, by the way. But here it has to dip. So now we're starting to get this like kind of curve of sorts. And if we did 454, it would start somewhere here. Maybe go here and here like that. And actually I have it in the next slide. If you're wondering what these lines are, sometimes those are lines that are independent of my topography lines. Maybe it's land, maybe it's like a structure of some sort, a building. Okay. Oh, I just realized I made a mistake. When I did my 458, I forgot to hit that point. So, I'm gonna have, let's see, I have a nicer one over here. Look at that. Yeah. Yeah, all right. But you get the idea, right? All right, and then you remove, let's say if you remove structure and put some other information, you can, this is what a map will actually look like sometimes. A little snippet of it anyway. And what's really cool is a lot of what we do will end up in a fancy computer program that will allow us to generate these 3D images. So from something like this, which you should know how to read now, you can see here that this is actually going down. It's a depression, and a computer can plot it, and this is really, really neat. And you can have, maybe you have seen these, if you've taken geology or something, there's these maps that they have that have actually, like topographic maps are easy to like acquire, you can find them, you can buy them, but they also have these more educational ones that actually show you the how like the 3D, it's like a 3D map. If you've never seen one, let me know, maybe I can show you one. I know that our geology department definitely has a few. Also know that there's tons of map symbols that as a civil engineer interpreting maps you should know, from roads to trails to pipes, churches, cemeteries, orchards, that kind of stuff. I don't expect you to memorize these at this point, but know that you'll encounter things like this, and it would be great for you to kind of know these. Okay, like this. Like this is what an actual topographic map, or actually no, just a survey of a particular place looks like, and it's a combination of topography lines as well as structures and symbols and all kinds of useful information, and you'll be working with things like this. All right, let's talk about profiles. So a profile of a topographic map is when we take, let's say, from line A to B and we slice it with a line. And then we're looking, it's kind of like we slice it and then we fold it and then we see its profile from the side. This is that, and you can create these yourself. So let me show you how. Okay, so what we're going to do here is we have a little bit of a map, and here you have a scale, and you're looking for A to B. So what you're going to do is you're going to take a little piece of paper, let's say right here, and you are going to draw a little line every time that you see a line. So like right here, right here, right here, right here, right here, 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 and here. Now, if you look at how separated those lines are, it might show you this, because I know that this line is 900, and my interval here seems to be, let's see, 20. So this is 900, this is 880, this is 860, this is 840, and then it starts kind of going up again, 840, and it's hard to tell because I cut the map, but just trust me with that, and this is 880, and this last one is 900. And then you're going to make a plot where the elevation changes are evenly distributed. And then you're going to plot those points. So 900 here, 800, 880, 860, 840, 840, 860. And this line connecting these lines is added at the very end. And this is actually showing you what is happening between A and B. Because you know that it's going like this, but showing you this way is much more descriptive than just being, well, it dips down and it comes right back up. Well, yeah, but how fast? And is it completely even? And in fact, it is not. You can see here some different points that give a little bit of variance to that terrain. So that's how you do a profile. I hope that made sense. You're going to have to do some profiles for homework. Okay. All right. So that's all I have for you for topographic maps. Now, the world of topographic maps is vast. There's lots of applications, but you know now enough information to interpret them and to understand what they're telling you. And it's all about communicating properly with maps and with things in 2 dimensions that are trying to symbolize things that in reality are 3-dimensional, right? Okay, great.